filling in a contingency table. We now have enough information to fill in an incomplete contingency table if we're given some additional information and use that to determine probabilities. Here's an example. A school is hosting a trip for grade 10 and grade 11 students. The possible destinations are Banff, Vancouver, and Halifax. The teachers collected the following information, and you can see the contingency table is incomplete. Additionally, the teachers have some other information. They know that given that a student is in grade 10, the probability they chose Banff is 9 in 25, and the probability that the student is in grade 11, given that they chose Vancouver, is 5 out of 9. Let's see how we can go ahead and fill in the rest of the table. So we can start off in the rows and columns where we only have one piece of missing information. We know the total has to come up to 750, and in that row we've got 302.25. So through subtraction, we can come up with 225. We're going to Halifax. Similarly, we can fill in the missing link in the totals column by looking at 750 minus 250 gives us 500. So 500 and 250 gives us 750. That's as much as we can do without getting into the further information. So now we take the information that says, given that a student is in grade 10, the probability they chose Banff is 9 out of 25. So we're given that a student is in grade 10, so we know we're working with just this row right now. And the probability they chose Banff is 9 out of 25. So grade 10 has 250 students, and the probability they chose Banff is 9 out of 25. We multiply those together, and we get 90. Once we've got that piece of information, we can fill in for grade 11. 300 minus 90 is 210. Now we'll access the next piece of information. The probability that the student is in grade 11, given that they chose Vancouver, is 5 out of 9. So we're given that they chose Vancouver, so we know we're working with this column, and we're trying to find the space that they're in grade 11. Because given Vancouver, we know we're working with that total of 225. So we've got 225 times 5 out of 9, which if we do the math, comes out to 125. Once we have that piece of information now, we can go ahead and fill in the rest of the chart. 225 minus 125 gives us 100 that are in grade 10 going to Vancouver. Now we can go across the rows. We've got a total of 500 grade 11 students, and right now we've got 335 of them. So we need another 165 to fill that up, and we can work either way. Now with this one, we've got 190 out of 250 going to Banff and Vancouver, so that means we need 60 going to Halifax. With that information now, we've managed to complete the contingency table. Let's answer a couple of questions now using the table. What is the probability that a student, chosen at random, is in grade 10 and chose Halifax? So we're looking for the probability they're in grade 10 and going to Halifax. So the probability of grade 10 and Halifax is 60. And because we're doing a random selection from the total group, that's total out of 750. We weren't given anything there, so we assume then it's therefore out of the total. And 60 out of 750 can be reduced down to 2 out of 25, dividing both top and bottom by 30. Question B says, given that a student chose the Banff trip, what is the probability that they are in grade 10? So this time we're given that a student chose the Banff trip. So the probability, we've got a given of Banff, and we're asked what is the probability that they're in grade 10. So probability of grade 10 given they're on the Banff trip. We're given the Banff, so we're looking at this column only, and the probability that they're in grade 10 is 90 out of 300. As soon as we're told that we're given Banff, so we're given that the student chose Banff, we ignore the rest of the table and we're working just with the numbers in the Banff column. Try the practice questions in the workbook and check your answers against the answer key.